So, brightness decisions are one of the most common and least questioned sources of long term LED stress. In many installations, brightness is set to satisfy expectations rather than actual need. The result is that a system looks impressive on day one but operates under unnecessary thermal and electrical load from the start. So, have you been to a place where the LEDs were really bright and then you come back a few months later or a year later and it's really dim? And in our market space, we've seen it happen a lot, especially because we've seen a lot of Chinese products come into the market space and really age quickly. And the place has no lighting value in such a short period of time just because of the thermal impact, for example, on the lights. So, unlike traditional lighting, LEDs don't fail suddenly when overdriven. They just actually age faster. And there's a curve that shows you as you send the drive current up with the LED, the lifespan goes down. Now you increase the brightness with the drive current, and those thin LED panel lights, which are extremely annoying and glary, and I really don't like it. We've seen a lot of Chinese variations of those products that they drive the panel at a very high current, electrical load, and you see how bright these things are. But guess what? In a few months, they're dim, they're dumb. They just dump it. So again, they age faster, and excess brightness increases heat. It accelerates component degradation and magnifies small application mistakes. The system still works in the beginning, as I mentioned. It just doesn't last as long or doesn't look as good over time. So, brightness isn't free. Every extra lumen has a lifespan cost. So, most common brightness assumptions electricians often hear are: let's make it bright and dim later. More output gives us more headroom. That's what the spec says. Now, these assumptions feel safe, but they are quietly increasing stress even if dimming is used later. A lot of people assume that brighter is better, and even though it's not the electrician's job to specify the brightness, you are becoming well equipped if you're contracted on your own without a designer to make key decisions that, one, protect the install, and two, protect the customer's eyes and the whole aesthetic feel of the space by choosing the right brightness. So, on your next LED install, ask what the minimum acceptable brightness is, not the maximum. Once you know the minimum, you just go a little above, not all the way to the top. Another thing you can do is identify whether brightness is being given by visual comfort, client expectations, fear of underlighting. Now, it's really the job of the lighting designer or the engineer to specify the brighting. But if none of those are on the job, don't try to overlight unless it's explicitly required. And if you're overlighting, you're choosing the right product that it's meant to overlight with. Identify whether brightness is being driven by visual comfort, client expectations, or fear of underlighting. Now, it's really the designer's job or the engineer's job to specify the lighting that's being used. But if you're lighting, you don't have to use the brightest light. Try to understand the application and know when it's appropriate to choose that brightness. So, if lights are being used because of brightness and using linear lighting, please ensure you have a lot of thermal management based on the application. So, example, if it's going to be run 24 hours and you want it to be bright, you want to ensure that you have a lot of thermal management. You also may want to enhance the lighting layout so you don't have to run the LEDs at maximum 100%. So probably you put more and you run all of them at 80% or 60%. But it's really key to understand what the client wants to get out of that lighting. So then flag any of the decision that prioritizes brightness over longevity. You're not changing anything yet, you're just identifying some stress points. I could tell you we revisited a residential install we completed over 10 years ago. I could probably show a clip of it here. The LEDs were still performing consistently. The only replacement needed was the driver. The job lasted because the application and the brightness decisions were conservative from the start, not because the product was special. So we used a normal 10 watt per meter LED, but we had a lot of thermal management in there. We didn't just put a raw strip, put it in a nice aluminum housing. And 10 years, the LEDs changed a lot. And this client used this product. I should put in this amount of thermal management. Okay. So in the next lesson, we'll use the brightness sanity check just to help you create that framework thinking pattern as a fast way to make brightness decisions without the math and the guesswork.